Okay, students, so we're going to look at the one more problem, example 4, with the LaGrange theorem, and we're going to determine the degree of the Taylor polynomial centered at x equal to 1 that can be used to approximate ln of 1.2. We're going to do it in a slightly different way. We're going to look at the first 4 terms, and we're going to look for, in the end, we're going to look at compare the first 4 partial sums of this, and we want to see what happens, and when we get convergence to 3 decimal places, we're finished then. So I'm not going to look at the n+1 or the remainder of this. What I'm going to do is I'm going to lay out these series. First I'm going to start with the first degree, second degree, and then I'm going to do the third and the fourth degree very quickly. Okay, so we first set out and we get our derivatives. So we go all the way up to the fourth derivative, and then we evaluate them at the center. And keep in mind that the summation, the series is over to the right here. That's what it's going to look like. So we have the derivative, the nth derivative, evaluated at the center over n factorial times x minus c, the center, to the nth power. And c in this case is 1, okay? X is equal to 1 is the center. So we want to approximate the value of ln of 1.2. So in the end, x is going to be 1.2 in our series. So first, laying out the series, you can see that I've circled the derivatives, so I'm just putting them in and then leaving the factorial in the denominator, not simplifying, just leaving them as is. Okay, so what I do is I start out the first degree, evaluated at 1.2, would give you, and we call this then, I guess I should say this in here, it's T1, and I do have it off to the side, but we're just going to use that. So T1 in this case is approximated by T1, which is just 0 plus, and then it's going to be 1.2 minus 1. And so that's going to give us a value of 0.2. Okay, so hold on to this for a second. And then we're going to do second degree, the second degree terms. So this is then going to be approximated by T2. And so that's going to be 0. And remember, that would be taking the first 3 terms there, right? So it's going to be the quantity x is 1.2 minus 1. And then we have minus 1 over 2 factorial times x minus, oh, not x, 1.2. 1.2 minus 1, and then that would be squared. So for T2, T, and I really should be T of 1.2, I guess it should be. But then what do we get a value here? We get that's equal to 0.18. So that seems like it's getting a little bit smaller, probably getting better. It'll get to be a better approximation when you extend the terms. And then we'll say T3. And as I said, I should probably have a 1.2 in the middle here. And so then that's going to be 1.2 minus 1 over 2 factorial times 1.2 minus 1 to the second power, and then it's going to be plus, it's going to be 2 over 3 factorial times 1.2, 1.2 minus 1 and cubed. And so then that would give us, so we extended it one more term, so when you calculate this, T of 1.2, then it's going to be equal to approximately 0.1826667 is what I get. So let's leave that here. Okay, so now that we have that, then we're going to go to the fourth degree term. Okay, so that's there, and then the fourth degree. So now if you notice, we had 2 degrees of convergence here, two decimal digits, and now I'm looking for 3. So we have 0.18, 0.182, and so when I plug this in, I'm going to look at the Taylor of the fourth degree of 1.2 to approximate. So now let's do this the easy way. So we already have that 0.1826667, right? We're adding one more term. So now remember, it's not a plus, it's going to be a minus in the alternating series. So then that's going to be minus 6 over 4 factorial times 1.2 minus 1 to the 4th power. And so T, and remember, 4 factorial is starting to get big here. So we get T of 1.2 is equal to, then I get 0.1822, 0.1822, 267. 182267, like that. 22167. That's interesting with the sevens and sixes. So we get this. So now once you see, here's another thing, once you see that it converges to 3 decimal places, it says that which degree can be used to approximate within 3 digits. That's the other thing that you can do rather than looking at the remainder here. You can look at it converging, and it'll continue to converge just like that, where you'll see that the T sub 5 is going to have T sub 5, and you can add, you can experiment with this to see what happens. 1.2 is going to have this 0.182, because remember, you're just increasing the number of terms. You're not moving further away from the center. So whatever else happens at that point, this will converge. T sub 6, the 6th Taylor polynomial, the 7th Taylor polynomial. It's just going to get more and more accurate with less and less error, okay? So that's what you had to do for that one. And I just want to send that to you quickly, and if I have time, I'll do one on example 5, and that's with e to the 2x. But I'll send this off to you so you have this. Tonight you're going to be doing, watching the videos for 8.10. It has to do with multiplying series, like the sine x times the cosine x. So you're going to be doing some distribution, if you will, with all the terms of one series to another series. And if you have any questions, bring those tomorrow. Okay? Have a good day.